Okay, right now this is the part where you learn the addition and subtraction of the matrices. So you see we have the two matrices, which is the 3 by 3 dimensions. So how do you adding the numbers in these matrices? Is just you add the corresponding entries like this. First step is you adding the corresponding entries is 12 plus 10, 9 plus 8, 14 plus 7, 10 plus 12, 5 plus 19, 3 plus 3, 7 plus negative 7, 6 plus 9, and 8 plus 3. So you get the final answer. The first one is 22, 17, 21, 22, 24, 6, 0, 15, and the last one is 11. So next one is the subtraction on matrices. The method to do this is similar than the addition of the matrices, but this is a different dimension, which is this one is 3 by 2 and also this one is 3 by 2. So just put the corresponding entries. 9 minus 15, 14 minus 9, 18 minus 10, 23 minus 8, 16 minus 14, and 2 minus negative 9. So you get the final answer. This one, the first one is negative 6, 5, 8, 15, 2, and the last one is 21.
Alright, today I would like to show to you how to solve the multiply matrices. Alright, for the first question, we got 2 times 3 matrices multiplied by 3 times 2 matrices, and at the end of the answer we must get 2 multiplied by 2 matrices. Alright, so for the first step, for the first row, we must multiply 1, 2, 3 to the 7, 9, 1, and the method is 1 multiplied by 7 plus 2 multiplied by 9 and plus 3 multiplied by 1. The answer is 28. So for the first step, for this position, you must get the answer 28. And for the second step, we must multiply 1, 2, 3 to the 8, 4, 2, and the method is 1 multiplied by 8 plus 2 multiplied by 4 and plus 3 multiplied by 2. The answer we must get 22. So for this position we must write 22. And for the third step, 4, 3, 4 multiplied by 7, 9, 1. So for the method is 4 multiplied by 7 plus 3 multiplied by 9 and plus 4 multiplied by 1, and we get the answer is 59. And for this position we must write 59. And for the last step, we change the position, this and this. So 4, 3, 4 multiply by 8, 4, 2. So for the method is 4 multiplied by 8 plus 3 multiplied by 4 plus 4 multiplied by 2, and we get the answer 52. And for this position we must write 52, and this is for the last answer, 28, 22, 59 and 52. This is 2 multiplied by 2 matrices. That's all for multiply. Divide matrices. Okay, we got 2 times 3 shape of matrices. Alright, so 14, 30, 22, 6, 18 and 10 divide by 2. So for the solution is every single this number you must divide by 2, such as this. Okay, 14 divide by 2, we get a 7. 30 divide by 2, we get 15. 22 divide by 2 and we get 11. 6 divide by 2, we get 3. 18 divide by 2, we get 9, and 10 divide by 2, we get 5. So this is the answer: 7, 3, 15, 9 and 11, 5. That's all.
Metric transposers are a neat tool for understanding the structure of matrices. Metric shape that you usually encounter are squareness and symmetry. Start with any matrix. You can transpose any matrix regardless of how many rows and columns it has. Square matrices with an equal number of rows and columns are commonly transposed, so this is square matrix. Turn the first row of its matrix into the first column of its row, and then repeat for the remaining row. As for the non-square matrix, the transposition is exactly the same. You rewrite the first row as the first column. For example, then I'll be showing you how to solve a 3x3 linear equation using the Cramer's rule. So we have this equation here. The first thing that you need to do is writing down the coefficient so that it will become like this. Then you have to compute the determinant. So take the first one, which is D. So for the first column, you take this 4, and then if you close this and this, you'll get -2 times -25 equals to 50 minus 8 times 3 equals to 24. And then for the second row, you'll take this 1 and then close this and also this. You'll get 3 times -25 equals to -75, and then -1 times 3 equals to 3. And then for the last row, if you close this and this, you'll get 3 times 8 equals to 24, and -1 times -2 equals to 2. And then just complete your calculation and you'll get this 0 for D. Moving on to dx1, to compute this, you just have to leave x2 and x3 column alone while you change the x1 column to the values on the other side. This one, put it in here so that it becomes like this. So to compute this, take 1 and then close this column and this row, and you'll get -2 times 25 equals to 50, and minus 8 times 3 equals to 24. And then for the second row, minus for the second row, take 1 and then close this one and this one, and you'll get 5 times -25 equals to -125, and then -3 times 3 plus 9 plus 8. Take this and then close this and this. So 5 times 8 equals to 40, and -3 times -2 minus 6. So after you complete all of this, then do your calculation as usual, and you'll get -130 for dx1. So for dx2, you leave this x1 column and also x3 column alone, and for the x2 column, you change to the values on the other side, which is this one. Put it right here, and as usual, take this 4 and put it right here, and then close this and this, and you'll get 5 times -25 equals to -125, and negative 3 minus negative 3 times 3 equals to negative 9. So plus 9 minus 1, this one. So you close this and this, and you'll get 3 times negative 25, negative 75, and negative 1 times 3, so positive 3, minus 8, this 8, and close this and this. So 3 times negative 3, negative 9, and negative 1 times 5, negative 5. So negative and negative, positive 5. So as usual, complete calculation, and you'll get negative 360 for dx2. And lastly, you leave the x1 and x2 columns alone, while the x3 column, you change it to the values on the other side, so it becomes like this. And as usual, take this 4, put it right here. So if you close this and this, and you'll get negative 2 times negative 3 equals to positive 6, and 8 times 5, 40, and minus 1, this 1, and then close this and this, you'll get 3 times negative 3 equals to 9, 1 times 5, positive 5, plus 1, and then close this and this, you'll get 3 times 8, 24, 1 times negative 2, and then complete calculation, and you'll get negative 110 for dx3.